Hi, in this video we will try to fit a very important machine learning algorithm which is used for both classification and regression, but it is best suited for classification problem, and that is known as support vector machine. Since it creates a kind of a optimal hyperplane that can separate the data points into different classes perfectly. So it is highly used for nonlinear data sets where the target variable is categorical in nature, or we have a classifier. The target variable is made up of different categories. For that, we'll be using a data set where we have one target variable which is categorical, and it's got three different categories, and these three categories are what, Shalimar, Vadura, and we have a final one that is Shohama. Then we have four different variables which are continuous in nature, and based on these four variables, by taking two pairs at the same time, we will try to fit and predict whether these four variables are, or whether this support vector machine algorithm which we will try to fit is able to completely classify the things perfectly, whether there's a kind of good classification or misclassification. We will try to see. For that, what we will do, we will use a library that is known as this library E1071. Okay, once we have recalled it, then first let us see the labels of our data set. That is, the name of my data set is SKUAST. Okay, then see the structure, which is very important. That is SKUAST, SKUAST. So since the variety is already converted to the factor level, this is very important. If it is in the character, then you have to use that as dot factor. Otherwise it will not work, or it will not, the functions which you will be trying to fit, they will not work. Then the first important step is to build up the model. So we'll be trying to build a support vector machine model using this default function SVM, and for that, what we have to do, we will write first the name of our target variable, followed by this tilde sign dot comma, which is a shortcut. Instead of writing all these explanatory variables one by one, we don't need to write them. Then data simply is equal to SKUAST. Okay, then let us see how this model will work. Get the summary of this model. So we have a summary of this model. Here we can see the type of class. This is a classification type problem, and by default the kernel function it is used as radial, and the cost function it is taken into consideration is 1. It is by default, and there are 51 support vectors. 8 belongs to Shalimar, 22 belongs to the Shohama, and 22 belongs to Shama, and 21 belongs to Vadura. Let us try to make a plot of it. For that, we will write model comma the name of the data set. Okay, then let us take two variables into consideration. First two, that is shoot length. Then we will try to use another, that is RootL. Okay, then after that we have to fix the other two variables, because in this data set we had 1, 2, 3 and 4 variables. Since we are trying to fix this model based on these two, by taking these two variables at constant level using some value. For that, we'll be using a function that is known as slice, and we'll make a list for this, and within this list what we will do, we will keep both these variables. So we'll be giving them some random or a hypothetical value. The last one is RootYield is equal to 4. Okay, let us try to see. So we have a plot here, and every different color is every different category, or the variety, or the class, or the group is defined by a different color. Vadura is something like burgundy, Shohama is yellow, and we have a little yellowish, whitish color or bright color in case of Shalimar. And if we will try to zoom it, let us see here. If you will see 1, 2, 3, 4, 5, 6, 7 and 8, these crosses, these are nothing, these are actually the support vectors. And if you will see in what we have done in case of here, the number of support vector in case of Shalimar, if you will see this color, this category, this pertains to Shalimar, and in this category we have 8 support vectors, which I will try to zoom it out again. We'll try to extend it like this. Again I will try to fix it. So if you will count them, 1, 2, 3, 4, 5, 6, 7, and including this we have 8. So similarly you can see we have almost 22 in this case, and this class is a bit different in comparison to these two. That means it's totally separated from these two categories, Shohama and Vadora. These Shohama and Vadora are a bit overlapped. So this algorithm which we have tried to fit is actually classifying this category Shalimar perfectly. For that, what we have to do, we have to see comparison between the actual and the predicted values, and for that we have to predict this model, and for that we have to do some prediction. So we will write the default code for prediction, that is predict, and within predict what we will write the name of the model, then the name of the data set. Then we will try to see to which categories each and everything belongs. So since we have a data of 150 observation, this doesn't look some useful thing, because we have to try to figure out each and every category to which number it actually belongs, how perfectly this is classified, the things are classified. For that we need to create a matrix, or we need to create a very important matrix that is known as confusion matrix, which is usually used in case of classification problems to test the reliability or the performance of a classification machine learning algorithm. And for that we'll be using this function table. Then we will give some name to the predicted values which we have just written in the previous step. Then actual, and within actual what we will do, we will write name of this data set. Data set is SKUAST. Okay, we'll use this $, and we'll try to extract this variety. It will create a matrix of rows and columns, where columns will be the actual values and rows will be the predicted values. So let us write C matrix. So there we have. So hence in this case the Shalimar is totally separated from these two classes, that is Shohama and Vadora. They are overlapped, and here you can see our model predicted the perfect, these values in the diagonals, they are correct classifications, and above and below they are some misclassifications. So we have only 4 misclassifications in our model, which is quite good. But if you will see, our model predicted 50 these instance or 50 these varieties in case of Shalimar, perfectly classified this, and this is visible by this plot also. And in case of this Shohama, 48 were actually classified and 48 are good classification, but there are 2 misclassification. This actually belong to this Shohama, but it has been by mistake or by error, we can say they are belong to this. So we can say this is a misclassification. The correct classifications are within the diagonals and misclassifications are above and below the diagonals. Like in case of Vadora, 48 are reclassified, but the 2 are misclassified in case of Shohama. Since it is giving an idea about whether there is a perfect classification or misclassification, but we want to try to get a one value which we can use simply just to see the authenticity or the reliability of our model. For that, what we will do, we'll get the value based on these actual and predicted classes, and we'll be trying to use the sum of all these diagonals, and then doing a ratio of all the number of the all instants which are available in this row column matrix. For that, we'll be using sum, then the sum of diagonals of what C matrix whole divided by the total of whole matrix, and this will give us a value which is nothing but an accuracy. So the accuracy of our fitted model is 97%. Since when we fitted the model, we have only used it, the default kernel was used as radial, and here you can see, and the cost function was 1. So if we will change it here, say for example we write kernel, then we will put the default radial function here, then let us use the cost value as 4, and let us try to do the things again. Summary model, so we have a different number of support vectors in each category. Earlier we had 8 in case of Shalimar, now we have 6 in case of Shalimar. Then let us try to make a plot. Then you can see the categorization is changed, although the Shalimar is still totally separable from rest of the two. Then after plot, what we will do, we'll again use this predict function, then we will try to create a matrix. Then this is the C matrix here. Okay, you can see there are only 2 misclassification. Shalimar is also perfectly classified, which is visible from this plot, and Shohama is also perfectly classified as visible from this plot, and also we have some good classifications of border, only 2 misclassification. Let us see this accuracy. So the accuracy, it has increased to 98%. Earlier it was only 97. So by changing the values of kernel and cost function, we can get the optimum, or we can optimize the accuracy of this SVM support vector machine, which is known as tuning. For that, we'll be making a separate video. Hope you like this video regarding the fitting and the prediction of the basic support vector machine for classification problem. Thank you very much.